Hello CS111 students, this is my problem set video for problem set 6 task 2 on Yelp data. And again, as a reminder, you don't need to watch these videos if you don't want to. I'm just walking through the instructions that are already on the website. You can do that yourself. But these are provided in case that this format is a little bit more helpful for some people. So task 2 is about Yelp data. Yelp is an app where people can rate businesses, was originally centered around restaurants, so that's a lot of the data they have, but extends to other businesses as well. And they have a public API where people can download data from them and use it for whatever purposes they want. So from their API, you can get data on different businesses, where they're located, and how many stars they're rated by the users of the app. So we have downloaded some of this data for you, and we have created two different dictionaries called MiniDict and MediumDict. MiniDict has 300 businesses in it, and MediumDict has 42,000 businesses in it. And this is still not a lot of data compared to what Yelp has. You could get probably millions of businesses if you wanted from their API. We provided a file called yelp.py in your PSO6 folder that has these defined as variables in it that you can import. You can also look at that file and see what the data looks like, and we encourage you to do this a little bit to try to understand what you're working with and how to use it. Do not change any of the stuff in that file, right? Because then your test that we've provided will not match up with what we have in the problem set description. So, how are businesses represented in this data set? Here we have a screenshot of what a business looks like on Yelp, showing a picture of the business along with the business name. The number of stars is shown with a little sort of like meter, and it also shows the number of views and the categories for the business as well as the business's address. In the data set, that business looks like this. So, first of all, the data sets are dictionaries. The keys of those dictionaries are these weird strings of random letters and numbers that don't have any meaning besides being a unique identifier for that business, right? The keys and values of a dictionary always have to have unique keys. We can't have multiple values for the same key. So each business is just randomly assigned a unique identifier so that we can put it as the key of the dictionary, and that business becomes the value. You can imagine that we could try to use like the name of the business, but then if you're a chain restaurant like McDonald's, there's maybe multiple businesses that have the same name, so that wouldn't work. Under that key in the larger dictionary, there is a smaller dictionary. And that smaller dictionary always has the same keys for each business. Those keys are address, categories, city, name, review count, stars, and state. That just happens to be in alphabetical order. Obviously, that's not an order that makes the most sense. Some of those things are grouped together. So the address plus the city plus the state, those three things tell you where the business is. Each of those things is a string. So in this case, the address is 4032 Butler Street, the city is Pittsburgh, and the state is PA for Pennsylvania. So those three keys each has a string value. The name key also has a string value that just tells you the name of the business. In this case, Crazy Mocha Coffee. And then there's a review count key that holds an integer, which is the number of reviews that business has received in Yelp. And a stars key that holds a floating point value, which is from 0 to 5, I believe. It might be 1 to 5. How many stars on average were the ratings for that business? Finally, there's a categories key, and the value for that key is actually a list of strings, which is categories that that restaurant belongs to, or that business belongs to. It includes strings like restaurants, strings like food, also strings for specific subgenres of restaurant like coffee and tea. And again, different businesses will have different things in that list of category strings. So that's how we represent a business, and you should start to feel your way around this data and think how you're going to use it and try to understand how it's organized. There are going to be 5 different tasks in this problem set, parts A, B, C, D, and E. And for these 5 different tasks, task A is, or part A, is to, given a business name in a Yelp dictionary, count the number of times that business appears in the dictionary. So say McDonald's, how many McDonald's are there? Part B, given a Yelp dictionary, build a list of the unique cities in that dictionary. Part C, find the top rated businesses in a given category in a given city. Part D, count the different categories in the entire dictionary that are above a certain number of businesses that they apply to. And then part E, the last part, is a simple question with an interesting and tricky solution. The question is just which place serves the best pizza in the entire dictionary. So of all the businesses in our business dictionary, which place has the best pizza? And now I'm going to walk through each of those parts a little bit. Let me just refresh the page here very quickly. Cool. So before you get started, just to make sure that you're sort of ready to dive into things, we have a very simple ungraded exercise for you. Here's some code for biz in Minidict, Minidict being one of those business dictionaries we provided. Indented line, print, Minidict, square brackets, blank 1, square brackets, blank 2. And your goal is to fill in those blanks so that what is printed is is one by one the names of each business in the dictionary are printed. And we have an example on the website showing what those names should be. So it should be fairly simple for you to figure out what should go in those two blanks to get this to print all the names of the businesses. But if you're having trouble with that task, we recommend you go back and look at the lab a bit to refresh yourself on how do we really access dictionaries, and especially how do we access these situations when we have like a list of dictionaries or a dictionary of dictionaries or a dictionary of lists or different data structures inside each other. So once you are comfortable with that exercise, you're ready to start. And part A is get business count. So you're defining a function called get business count. It has two parameters. Parameter 1 is bizdict, the dictionary of businesses that it's going to process. Parameter 2 is business name, the name it's going to look for. It's going to return an integer, which is the number of businesses with that name in the given dictionary. And we've provided some examples. For example, in the Minidict, there are two businesses named Pizza Hut. Note that this function should be case insensitive. So it shouldn't matter whether you give it the business name in upper or lowercase. It should be able to find businesses in upper or lowercase that match those letters. Obviously, if you give it a name that isn't in the business dictionary at all, then you should be returning the value 0. Okay, part B, collect all the unique cities in a given dictionary. So we're defining a function called unique cities, takes one parameter, the business dictionary, and it's going to return a list of strings. Each of those strings is going to be the name of a city, and that list is going to list all of the cities in the dictionary. Of course, there are many businesses in each city, so we don't want to have multiple copies of the same city appearing in this list. Just one copy of each city that appears in any business in the dictionary. Okay. Again, we've provided an example of what that should look like in the web page. Part C is to find businesses that meet certain criteria. So the function is called find businesses. It has 5 parameters. Parameter num, the business dictionary, the data set to work with, right? Parameter 2 is a category. So we're only going to look for businesses that have that category as one of their categories. Parameter 3 is a city. We're only going to return businesses that are in that city. Parameter 4 is a star limit. We're only going to return businesses that have that many or more stars as their star rating. And parameter number 5, the last parameter, is min review. It is the minimum number of reviews, and we're only going to return businesses that have that many reviews or more. So this function is going to return a list of tuples, not just a list of strings. And each of those tuples is going to contain the name, address, and number of stars for a particular business that meets all of the criteria that we just laid out. So, for example, if you called find businesses with the medium dictionary and said the parameters are category restaurants, city Las Vegas, min stars 5, min reviews 500. That would return a list showing us all of the restaurants that are in Las Vegas with at least 5 stars. That's the maximum, so they'll all have exactly 5 stars, and at least 500 reviews. We've given, again, some examples of what the correct results should be for various invocations. Note that in some cases, the correct result is to return an empty list, because in some cases, if your criteria are too strict, there just aren't any businesses that meet those criteria. Note in these examples what the output looks like. It is a list of tuples, right? And each of those tuples has a business name and then a business address, not including the city or state, just the street address, and then a number of stars. So those 3 pieces of information are included in the tuple. Okay, part D is to find all categories in a dictionary that occur above a given threshold. So, if a category is just listed by 1 or 2 businesses, maybe we don't care about that. But if there's 1,000 businesses with that category, that's probably a significant category. This function is going to be called find categories, and it has 2 parameters, the data to work with and the threshold as a integer, which is how many occurrences of that category is going to be required to count in terms of the list we're going to return. Again, it returns a list of tuples, not just a list of category strings. It returns a list of tuples where each tuple contains the name of the category and the number of businesses in that category. So we have some examples of the correct results. For example, in the mini-dict, if we look for categories with 50 or more occurrences, there are only 2. There's restaurants with 106 occurrences and shopping with 50 occurrences. Right, and notice that the minimum is not exclusive. If we exactly match that minimum, we're still get included. It's only if you're below that threshold that you get excluded. So, again, more examples on the website for you to look at and compare your output to. Part E is the last part of this problem set, and it is best pizza place. Just has 1 parameter, the data set to look in, because it knows what it is looking for. It is looking for a business which has the pizza category, and it's looking for a business that has the highest number of stars, and then among businesses tied for the highest number of stars, it's looking for the one that has the highest number of reviews. So if we have, say, a 5-star place and a 4.5 star place, and the 5-star place has 5 reviews, but the 4.5 star place has 10,000, well, the 5-star place has more stars, so it is the winner there. But if we had 2 5-star places, and one of them had 100 reviews and the other one had 101, the one with 101 reviews is the winner, and we ignore the other one. So again, we're looking to maximize the number of stars, and once we find businesses that have that maximum number of stars, we're looking to maximize the number of reviews. Now, it's possible there are multiple places that are both tied in terms of having the highest number of stars and tied in terms of having the highest number of reviews. If that's the case, they should all appear as part of the result, because the result of this function is a list containing tuples with the name, address, city, and state of the business in question. Now, normally, that's only going to be a single tuple in that list if there's just one business. But if there are multiple businesses tied both in terms of stars and in terms of reviews, and they're the highest in both those categories, then we would have multiple businesses in that result. That's not the case for the mini-dict or medium-dict, which is the examples that we showed here. For the mini-dict, the best pizza place is Cavanis Studio, no address given, in Phoenix, Arizona. For the medium-dict, it's Inforno Pizza, 35840 Chester Road in Even, Ohio. Now, Cavanis Studio isn't actually a pizza place. We don't know why they put pizza in their categories. Maybe they thought that people like ordering pizza and would see them more often and that people might want graphic design with their pizza, we don't know. In any case, that's your goal for this task, and that is this part. That's the last part of this task in the problem set, and so that's it for me for this video.